Good morning, students. Welcome back to this data structure class. So we are discussing about one application of the list, that is polynomial addition using linked list. Okay. So now you know how to express a polynomial as a linked list. Okay. This is the figurative representation of a polynomial in the form of a linked list. Then what is the structure that is needed for that polynomial node? That is, one is a coefficient node and another is exponent node and another one is a pointer node. This is the function to insert a term into a polynomial. This is the function for reading the contents of a polynomial. When we try to read a polynomial, we ensure that the exponents are in the decreasing order and there is no zero coefficient. Okay, that's what we have discussed about reading polynomial. Then writing polynomial is similar to displaying the contents of a polynomial. A pointer is given to the first node of the polynomial, then the contents of that coefficient and exponents are displayed, then the pointer is moved to the next node, next term, like this, one by one, next term, until the pointer comes to the null. Okay, then this function is for adding two polynomial. This is a very important function. Here there are various cases of polynomial addition are considered. One is two polynomials having the same number of terms and equal exponents, and second case is two polynomials having same number of terms but different exponents. Then the third case is two polynomials in which the first polynomial has more terms than the second polynomial, and the fourth case, the two polynomials, the first term has lesser number of terms than the second polynomial. Okay, like this, various cases. Okay, all of them are taken into consideration in this loop. In this loop, as long as the first polynomial is not equal to null and the second polynomial is not equal to null, that is, the pointer for the first polynomial and the pointer for the second polynomial is not equal to null, their exponents are compared for equality. If they are equal, then their coefficients are added. Then if the exponent of the first polynomial is bigger than the exponent of the second polynomial, then the particular term of the first polynomial is taken to the result, then the pointer is moved to the next term. Otherwise, if the exponent of the second polynomial is bigger than the first polynomial, then the term is taken to the result. Okay. Then when we traverse like this, sometimes one polynomial may exhaust all the terms. That is, when one polynomial has more number of terms than the second polynomial, chances are that the second polynomial is null and the first polynomial is still having some values. That is this case. That is, while the first polynomial is still having more number of terms, we copy those terms to the resultant polynomial. Then otherwise, similarly, second case, when the second polynomial is having more number of terms than the first polynomial, copy them to the result. Okay, that's how we have displayed. Now we have to use all these functions in a main method, in our main method. That's what we are going to do now today. Main, it is a simple one. It is almost over. So here now I declare various pointers for the given polynomials. Star P1, star P2, comma, star P3. Okay. Now I need a variable to choice to move through the menu. Okay, do. What do I do? Get the value for choice. Okay. What to do? Do I want to read the contents of the first polynomial or second polynomial, or do I want to display the polynomials, or do I want to add the polynomials, or do I want to display the result? Well, these are the various activities that I am going to do. So switch choice, switch choice, case 1. Case 1, I read the first polynomial. What is the name of the function? Name of the reading polynomial is the name of the function. It has a formal parameter, that is a reference polynomial parameter. Okay. So case 1, reading polynomial. Then second one is case 2. Case 2, read the second polynomial. Okay. Then the case 3 is display the contents of the first polynomial. Display case 4 is display the contents of the second polynomial. Okay. Case 3, the name of the function is right polynomial. Okay. Right polynomial of break. Okay. Case 4, second polynomial. Okay. Now what is case 5? Case 5, add the accepted polynomials. That is, what is the name of the function? Add poly. Yes, add poly. That we are doing, calling it now. Add poly of what are the polynomials P1 and P2, and store the result in P3. See, add the polynomials P1 for this x1, P2 for this s2, and P3 for this result. See, this result is a reference parameter. So on completion of this one, the value of this result is given to the corresponding P3. That's what we are going to do. Add poly P1, P2, P3. Break. Then case 6. Display the result polynomial. So P3. The result is available in P3. Okay. Over. how long we do this while choice is not equal to any of this 1, 2, 3, 4, 5, 6. So while choice not equal to maybe 0, while choice not equal to 0. That's all. So when we give the value 1 for this choice, the first polynomial is red. When we give choice 2, when we give 2 for the variable choice, we read the second polynomial. When we give value 3 for this choice, first polynomial is written. When we give choice 4 for choice, the second polynomial is written. When choice is given the value of 5, the accepted polynomials P1 and P2 are added and the result is stored in P3. When we give choice is equal to 6, the result value P3 is displayed. That's how we have successfully, it's a do-while loop. It's a do-while loop and it is successfully repeatedly executed as long as the choice is not equal to 0. So this you can try it out in your home and you can try it out in your home. Okay, it's a workable example, workable implementation. Okay. Okay. Now, this is for addition of two polynomials. We can add one more function that is multiplying two polynomials. All the functions are same except we have a function for multiplication. Okay, that we can consider in this class itself. Okay, I add one more function, maybe mulpoly. Okay, void mulpoly. This also will have the same functions like poly s1 s1 comma uh, poly star s2 comma then poly star reference result. This multiplication is much easier than addition because we don't have to consider whether the polynomial, first polynomial is having less terms than the second one or like this, whether they are having equal terms or non-equal terms. Nothing we need to worry about that. It is take the first term of the first polynomial, multiply it with all the terms of the second polynomial. Then take the second term, multiply it with all the terms of the second polynomial. Like this. It is a very simple work only. So that's why I have incorporated that also in this program itself. Star Q. Okay. Then when I multiply the coefficients, okay, I need one variable, so I call that as CPRO, coefficient product. Okay. Then I need one more variable. Okay. A sum. Then To traverse through this polynomials from one term to another, I give the value of this S1 to the variable P. Okay. P is equal to S1 and Q is equal to S2. Q is equal to S2. And the result, I create the first term of the resultant polynomial, dummy node, equal to nu of poly. Nu of poly. So what happens here? Dummy node is created. Okay. And tail is given the value of that dummy node. Now both tail and the result are pointing the same dummy node. Okay. Now we are going to multiply the polynomials. I take every term of the first polynomial, multiply with all the terms of the second polynomial. So that I put that into a while P not equal to null, because P is a pointer for the first polynomial, while P not equal to null. What do I do? While Q not equal to null, what is that answer coefficient? C pro equal to product of the first coefficient and the second coefficient. So first coefficient is P reference coefficient multiplied with product of the second with second coefficient, that is Q reference coefficient. Okay. Then after multiplying the coefficient, the corresponding exponents should be added. So exponent sum is sum equal to P exponent plus Q exponent. P reference expo plus Q reference expo. That's all. Now we have the first term of the resultant polynomial. So you insert that. Insert term. This coefficient product, comma exponent sum, comma then the tail. Okay. So we have taken the first term of the first polynomial. We are multiplying with every term of the second polynomial. First we have multiplied with the first term of the second polynomial. Then we should consider for the next of subsequent terms. For that, Q should be moved to the subsequent nodes. So that's what we are doing. We are going to do it now. Q is equal to Q reference next. Q is equal to Q reference next. Okay. Once all the terms of the second polynomial are considered, then Q should be moved to the first term for multiplying the second term of the first polynomial with all the terms of the second polynomial. So Q is a pointer for the second polynomial. Q is equal to S2. Okay, Q is equal to S2. Okay, then you go for second term of the first polynomial. So P is equal to P reference next. P is equal to P reference next. Okay. So we are taking every term of the first polynomial, multiply it with every term of the second polynomial. That's all. Now tail reference next is equal to null. Then P is equal to result. The result is equal to result reference next. Let it be. So this function multiplies the given two polynomials. This I can incorporate in this program itself. So add two polynomial, then I can say case 6 multiply of P1, P2, P3, P1, P2, P3. Then this becomes case 7. This becomes case 7. So in a single program, we are adding two polynomials and we are multiplying two polynomials. Everything is taken into consideration. Okay, this multiplication is a simple work. Take every term of the first polynomial, multiply with every term of the second polynomial. Once all the terms of that second polynomials are over, reset the pointer for the second polynomial to the first term, then improve the pointer for the first polynomial to the next term. Like this we will do. Then we can add all the term, all the work, all the multiplications. Okay, so this is a very good example of linked list. Addition of polynomials can be done using the arrays, using the using the list using arrays. Okay, possibly we will consider that in the next class, how to perform polynomial addition using arrays. That is also a very simple example that we will see in the next class. Okay, see you tomorrow.